what is the Fourier series? Suppose we have one function fx that is defined over some interval. So let's say its interval is c to c plus 2l. So c plus 2l is a general interval. So let's first write down, then I'll discuss what is that. So if fx be defined on c plus 12 and satisfies Dirichlet condition. So I'll come later what is the Dirichlet condition after defining that Fourier series. Then the function fx can be approximated by a trigonometric series involving sine and cosine as follows. As fx is a0 by 2 sum of so this a0, an and bn, these are called Fourier coefficient. We have to find what is that a0, an and bn. So in the exam basically you have to given one function fx and you have to ask that find the Fourier series of this function. Okay. So we have to find that a0, an and bn. So this a0, an and bn is called Fourier coefficient, where and this a0, an and bn, how to calculate? I'll write. So you have to calculate a0, an and bn. Okay. So first write down 1 by L, 1 by L, 1 by L everywhere. Then integration, integration, integration. Range is same for all this one. C to C plus 2L. For the first coefficient a0, only integrate the function fx. For n, integrate this function fx into cos of n pi x by L dx. For Bn, calculate this function fx, integration of fx, sine of n pi x by L dx. Okay. So basically we have to find these three coefficients from the given function. This is our aim for finding the Fourier series of a function. Okay. Now I'll talk what is that Dirichlet condition. So all these functions that we find the Fourier series, these functions should satisfy the Dirichlet condition. If it does not satisfy the Dirichlet condition, then we cannot find the Fourier series for that particular function. So what is that Dirichlet condition? Suppose we have a function, let's say fx, defined over some interval, let's say same interval c to c plus 2l. Let fx be defined over defined on c plus 12 will satisfy Dirichlet condition if, so first condition is that the function should be periodic. Second condition is that function should be single valued. Third condition is that fx can have finite number of finite discontinuity. In that interval. Number 4 is that fx should have finite number of maxima and minima in C to C plus. So first condition is periodic, that we already know what is that periodic function. The next one is that single valued. So up to now, whatever function we come across in our classes, all are single valued. There are multi-valued function, we can say, like say root of the any number. So that is the multi-valued function, we can take example. So fx can have, third condition is that fx can have finite number of finite discontinuity. Finite discontinuity means that it can only have jump discontinuity. It cannot have infinite discontinuity at any point. The last point is that it can have finite number of maxima minima in the interval. It cannot have infinite number of maxima minima in that interval. If that function satisfies all these four conditions, then this function can be approximated by a Fourier series. Now I will take one example and show you how to find the Fourier series for that particular. Find the Fourier series. Series or expansion for fx is x square in minus pi to pi. So this is the interval minus pi to pi. In this interval the function is defined like fx is x square. Now we will find the Fourier series or Fourier expansion for this function x square. Now first we have to find what is the L. So how to find the L? So the first we write C is minus pi, because in our definition the function is defined to C plus 2L. So that is any general interval. From that interval we can find any interval minus pi to pi or 0 to 2 pi or any arbitrary interval. So C is minus pi here and C plus 2L is pi. Now we have to find L. Just put that C equal to minus pi in the second equation. So it will be minus pi plus 2L is pi. So this means 2L is 2 pi. So L is pi. So L is pi. Now first we find what is A0. So A0 is 1 by L integration C to C plus 2L fx dx. Now L is pi, so it is 1 by pi integrate to C is our minus pi to pi, fx is our x square dx. Now see that x square is a even function and we are integrating this x square over a symmetric region minus pi to pi. Therefore this integration will be 2 by pi 0 to pi integration x square dx. So this is equal to 2 by pi cube by 3. So this is 2 pi square by 3. So we find out first Fourier coefficient A0, that is 2 pi square by 3. Now we will find the other two Fourier coefficient n is 1 by L integration c to c plus 2L fx cos of n pi x by L dx. So this is equal to L equal to 1 by L equal to pi. So this is 1 by pi. C is our minus pi to pi. Fx is our x square cos of n pi x. L is our pi dx. Okay. Now pi got cancelled, so this is 1 by pi minus pi to pi x square cos of nx dx. Okay. Now see here, x square is a even function and cos of nx also a even function, and product of two even function again a even function, and we are integrating in a symmetric region. Therefore we can write this is as 2 by pi 0 to pi x square cos of nx dx. Now we integrate this function by the chain rule of integration. So x square first it is fixed, then integrating the cos x once, minus of differentiating x square to x, integrating this function again, minus of cos of nx by n square plus 2, differentiated this function is 2, integrating this function again, minus of sine of nx by n square, limit is 0 to, so this is n cube not n square, so n cube sine nx by n cube. Okay. Now you put the limit, therefore an will be 2 by pi, that is already there. Now this is, if we put pi, so it will be pi square sine of n pi, that is 0. So this is 0. Second part is minus and minus, so this is plus, 2x is pi, and cos of n pi, that is minus 1 to the power n, and by n square. Now again sine of n pi, that is 0. Now minus of, we put the limit 0, so this is 0, this is 0, and sine of 0 is 0, so plus is also all are 0. Okay. So only remaining thing is 4 by n square, pi got cancelled, minus 1 to the power n. So this is our n. Now we find what is bn, the last coefficient. Now bn is 1 by pi 1 by L c to c plus 2L fx sine of n pi x by L dx, right? So this is 1 by pi minus pi to pi x square sine of, now L is pi, so pi got cancelled, so it will be nx dx. Now see, x square is even function and sine of nx is odd function. So product of these two functions will be a odd function, and we are integrating this over a symmetric region. Therefore, this value of this integration will be 0. So our Bn is 0. Hence, we write the function fx x square by this way. So we got a0 is 2 pi square by 3, an is (4 by n square minus 1 to the power n), and Bn is 0, right? So x square will be equal to a0 by 2. So 2 pi square by 3 by 2, so this is pi square by 3 plus sum of n equal to 1 to infinity n. So n is our 4n square minus 1 to the power n, then cos n pi x by L plus Bn. Bn is our 0. So this term will be 0. So L is our pi. Therefore x square is pi square by 3 plus sum over n equal to 1 to infinity 4n square minus 1 to the power n cos of nx. So we write this as equation number 1. Okay, that's it.